Hello. I hope you had fun watching the experiment in the previous video where we learned the volume and the capacity of right circular cones using 3 conical vessels and a cylindrical one. This experiment made it so easy to remember the formula, right? We saw how the capacity or volume of a right circular cone is 1/3 the volume of a right circular cylinder of the same radius and the same height. Now, this helped us derive that the capacity or volume of a right circular cone is equal to 1/3 pi r squared h. Here, r is of course the radius of the base and h is the height of the cone. Now, apart from these basic terms, cones also have a slant height, which, as you know, is generally denoted by L. So, now that we have recapitulated all the basic terms and also the formula, what's the next logical step? To use them and solve problems, right? In this video, we'll be doing just that. So, ready to tackle some freshly curated questions? Let's roll. We'll begin with a question that will test how well you remember what I have taught you so far. Here's what it looks like. It states that a right triangle ABC with sides 5 cm, 12 cm and 13 cm is rotated about the 12 cm side. Find the volume of the solid so obtained. If the same triangle ABC is rotated about the 5 cm side, find the volume of the new solid so obtained. Also, find the ratio of the volumes of the two solids obtained. Sounds tricky? Isn't at all. Let's just visualize and find out. As per the question, there's a right triangle ABC with the following measurements. Now, in this orientation, AB happens to be the height and BC the base. So basically, this right triangle is being rotated twice. First about the height AB and then about the base BC. But not about AC, which is its hypotenuse. Now, what happens when we rotate a right triangle about its non-hypotenuse side? We get a right circular cone. We have studied this already, right? So, basically, this right triangle, when rotated about the 12 cm side, gives us this right circular cone. And when it is rotated about the 5 cm side, it gives this other right circular cone. All we have to do is find the volume of each of these cones and then compare them to get the ratio of their volume. So, now that we have understood the approach, let's get on with the calculations right away. For the first cone, its radius, say R1, is the same as the base of the parent triangle, which is 5 centimeters. Similarly, its height, say H1, is the same as the height of the parent triangle, which is 12 centimeters. So, on substituting these values in this formula, we get the volume of the first cone is equal to 1/3 pi into 5 into 5 into 12 cubic centimeters. The common factors obviously get divided and we arrive at 100 pi cubic centimeters. Now, we may further simplify this to get 314.29 cubic centimeters. But I am choosing to let it stay 100 pi cubic centimeters. Give me a few minutes and you will know why. Coming to the second cone, its radius, say R2, is of course 12 centimeters and its height is 5 centimeters. So, on substituting these values in this formula, we get the volume of the second cone is equal to 1/3 pi into 12 into 12 into 5 cubic centimeters. The common factor gets divided and we finally arrive at 240 pi cubic centimeters. Here too, we can simplify this to get 754.29 cubic centimeters. But it's better to leave it this way. We will now see why. So, the volume of the first cone is 100 pi cubic centimeters and that of the second cone is 240 pi cubic centimeters. Now, to find the ratio of the volume of the first cone to that of the second cone, we just divide the volume of the first cone by the volume of the second cone. Now, this is same as 100 pi cubic centimeters by 240 pi cubic centimeters. Now comes the reward of your patience. If we had simplified each of these volumes to 314.29 cubic centimeters and 754.29 cubic centimeters, it would have been extremely difficult to divide them, right? But because we didn't simplify, dividing them becomes a piece of cake and we get the required ratio is equal to 5:12. So, summarizing, the volume of the cone obtained by rotating the right triangle about the 12 centimeter side is 100 pi cubic centimeters. That obtained by rotating about the 5 centimeter side is 240 pi cubic centimeters. And the ratio of the first volume to the second is 5:12. So, now that all the three requirements are met, our question is solved successfully. That was a pretty interesting question, wasn't it? Now, before visualizing the formation of the cones, you may have felt that the volumes are going to be the same. But now that we have visualized it, I'm sure you know that the reality is completely different. That's the power of visualization. It helps us in solving problems more than anything else. So, let's just exercise the power of visualization in this question as well. It states that a conical tent is to accommodate 11 persons. On an average, each person must have 4 square meters of space on the ground and 20 cubic meters of air to breathe. And we have to find the minimum possible height of the cone given that the ground is exactly enough for the allotted number of persons. Sounds like an interesting one, doesn't it? Let's visualize. As per the question, there's a conical tent that accommodates 11 persons. Quite a big tent, must say. Anyway, on an average, each person needs a space of 4 square meters on the ground. This means that one person may need 6 square meters of space. One person may need just 2 square meters of space. One may need a square space. One may even need a circular space. But on an average, each person needs a space of 4 square meters on the ground. Now, square meters represents area, right? So basically, 11 persons need an area on the ground same as 11 into 4, that is 44 square meters. But how is this area related to the cone? Well, if you think about it, this 44 square meters of area is nothing but the base area of the conical tent. And because the ground is exactly enough for 11 persons, the base area is exactly equal to 44 square meters and not less or greater. Makes sense, right? So, if the conical tent has base radius r, then its base area would be pi r squared, which implies that pi r squared is equal to 44 square meters. Quite interesting an observation, isn't it? So, should we find the value of r? Let us first see what the other piece of information tells us and then we will decide accordingly. We see that each person needs 20 cubic meters of air to breathe, which indicates that the 11 of them would require a total of 11 into 20, which is 220 cubic meters of air to breathe. Now, what does cubic meters of air represent? Volume of the air inside, right? So, as long as we make sure that the volume of the air inside the tent is 220 cubic meters or more, we are good to go. If the volume of the air is less than 220 cubic meters, the people might suffocate. So basically, the minimum volume of air required for 11 persons to breathe is 220 cubic meters. Now, don't you think this volume of air would be the same as the capacity of the tent? Of course it would. So, if we take the height of the conical tent as h, its capacity would be 1 by 3 pi r squared h, which implies that the minimum value of 1 by 3 pi r squared h is 220 cubic meters. Now, the question essentially asks us to find the height of the cone, right? Which we took as h. So, how do we find the value of h using these pieces of information? Isn't it intuitive? We just divide 1 by 3 pi r squared h by pi r squared. So, 1 by 3 pi r squared h by pi r squared is equal to 220 cubic meters by pi r squared square meters. Now, pi r squared is just 44. So, on substituting this value on the right hand side of the equation and then dividing the common factors, we finally arrive at 1 by 3 h is equal to 5 meters. Then h is equal to 15 meters. So, summarizing, the minimum height of the conical tent should be 15 meters. Hey, you can't deny that this was an interesting question too. And we solved it using our unlimited power of visualization. Visualization, if directed well, will take you places. Depends on where you want to go, that is. If we are talking about going to solve the problems, you don't really have to go anywhere. There's a galore of such amazing problems right in your app. So, if it pleases you, watch this video once again for a greater understanding and then head to the quiz section to solve the problems. I'll be seeing you super soon with another amazing video. Till then, keep visualizing and keep realizing.